blow-off. Okay. So, before we get fully started in our lesson today, one of the things that we're doing is they're doing a little pre-teach on the next couple lessons that we're about to do. This is lesson 15, and we're doing a little pre-teach of lessons 17 and 18. And I'm about to really totally blow your mind. Are you ready? And when I say what it is, you're going to go, what on earth is she saying? And then whenever I say it or teach it to you, you're going to go, oh my gosh, this is so easy. Okay.
My head's gonna blow off.
Oh, it's going to blow off, and then whenever I teach to you, you're going to go, oh, this is so easy, and it's going to come right back. So, it's writing fractions as decimals. Okay, you ready? And you go, oh! And it's gone. Okay, writing a fraction as a decimal. So, if I have this, say that, 7 tenths. 7 tenths. 7 tenths. 7 tenths. 7 tenths. Back on your bottom.
I know it all the time. It's like on it.
7 tenths. So, Mr. Dole, you divide a number by a power of 10. Mr. Dole, divide left. Right? So you got 7 decimals there.
And there's 1 0. There's 1 0. So you put the decimal over to the left side.
Right? Right? So if I have,
That's gonna be 2.2.
huh? Because a fraction is dividing.
So basically,
2 tenths equals 2 divided by 10. This is one of our test questions.
Right. Okay.
It's 2 divided by 10, which would be 2.
Yes. Oh, got it.
2 tenths. 2 tenths. 2 tenths. Oh, okay. 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 How many times can we say okay in 1 sentence? Okay.
Okay.
Okay, okay. So, what if I have...
.011.
Okay, so, if we have this... This is a thousandth. This is 11 thousandths. This is tenths. This is hundredths. This is
I knew it'd be
thousandths. But it's not. This is 11 hundredths. Because you have 11 divided by 100. You have 11 with the decimal here. When you have a whole number, the decimal's at the end.
Oh my god.
1, 2.
I'm dumb.
It's okay, they did it in first period too. You're wanting to put that 0 in the front. Because if I had 2 divided by 100, you would have the 0. But I have a 2-digit number, so you won't have the... Right. And it's okay. It's only the first time you've done it.
It's like
Right.
it's like when you go up like to 100 and you find the 0 and go back up and you use 2 and then go back up and use 3. You only have a 0 and it's a 1 digit number. So yes. It would be .02.
Excuse me. Because it had to move 2 places. So, it's here because it had, just like we did in first quarter, if I had 2 divided by 100, the decimal's here. It had to move 1. It had to move again I have to put something in that gap.
Under.
I have to put a 0. You broken again, huh? So, this is going to be what we're doing in lessons 17 and 18. Okay. So, if I have a problem, and it looks like Kendra spent 1/3 of her allowance. You don't have to write this. On a book. Oops. And 2/5 on a snack. So Kendra spent 1/3 of her allowance on a book and 2/5 on a snack. If she had $4, 2, 3, I don't know, remaining, I do that every time, remaining after purchasing, I'm just writing them, because it's supposed to be the book and the snack, and I'm not writing that, them, arm size. That's some big writing. What are you talking about? I have to write big. What? Was the total amount of her allowance? That's why I told y'all not to write it. Okay. So, I mean, we could easily figure out probably, well, no, we can't figure out how much she spent on the book and the snack because we really don't know how much that stuff was. But we can figure out how much her allowance was. So, is this something that I can just do like a 1/3 times 2/5?
No.
No. So there's a strategy that I need to use to be able to figure out that we worked on Friday.
You can draw the,
Okay. Tape diagram. Tape diagram. So that I know how many pieces to put in it. I've got a 1/3 up there. I've got a 1/5 right there. But I know that I need to figure out the total allowance. Total allowance. So how can I figure out how many pieces I need to put? I've got a 1/3, I've got 2/5. What could I do?
You could do 3 because 3 is going to get 5.
I could, but then what would I do with my 3/3s?
Split it in thirds.
I could, but then what would I do with my 5?
5 would be how many, you're gonna die if you don't kick me.
Oh, I think if I don't kick you. Alright. What?
You can add 2 this and 1. No, you can't.
No. What could you do, Lexi?
Couldn't you turn the third into this and 15?
I could. I could turn the thirds and the fifths into 15ths. Give them a common denominator.
I was thinking that, but I'm like, wait, but you got the other thing to do too.
So, 1/3. If I'm doing 15ths, 2/5 with 15ths. If I'm doing 1/3 to go to 15ths. I'm not worried about that. So that would be 5/15ths. 5 into 15. 3, and then the 2 would become a 6. So now that they have a common denominator, I can complete my tape diagram. So I need to try to give this 15 pieces. I ended up with a really big 15th piece, and it drove me insane. So let me see if I can do it real quick. So 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. Yeah, I did it. It was so ugly this morning. I had to fix it. Okay, so I have 15 pieces. 5 of them are for her book. So 1, 2, 3, 4, 5. I'm going to label that her book.
Oh, I get this now. Oh.
So 1/3, which is the same thing as 5/15ths. Those are equivalent. Those are the same thing. You see what I'm doing? The same thing. 6/15ths, which is the same thing as 2/5.
Oh, you lost me because if you did 5 times 1 to get up there, then that. Oh, I see now. I'm dumb.
1, 2, 3, 4, 5, 6.
I am
Here's the
so.
snack.
All that's left is 4.
Yes.
If she had $4 remaining after purchasing this. So this, 1, 2, 3, 4.
She had $11.
4 15ths left. So she had 4 out of 15 left over. This is her $4 left. 4 units left. Don't tip your chair, please. So she had 4 units left. 4 out of 15. So can I figure out? So 4 out of the 15. So can I figure out now what each unit is worth to figure out how much her total allowance is?
Yes.
Holy moly.
If you don't, I'm probably gonna pass.
6/15 minus.
So when you have 4/15, you could just add. You know how there's 11 between 15 and 4, so you add those.
Ignore that. She had 4 left.
Every single section is $1.
Every single section is 1. 1, 1, 1. So if these are 1, what are these?
1.
1. So how much money did she have?
$15.
She had $15.
$15. No, I only have $15.
She had $15 for her total allowance.
Can't get a yachty.
Okay. So last week we practiced with like a unit to a unit. And a unit is just when your numerator is 1. Then on Friday we practiced a non-unit to a unit. And all that means is when your numerator is not 1 to a unit. Now we're going to do non-unit to a non-unit. And so That's what we're going to do today. The steps are the same. So, if I have 2/3 of 3/4, the first thing I'm going to do is a rectangular model, because we need to become really good at modeling it and working it. So we're going to model it with 4 sections. How many am I going to color in?
3.
3. We have 3/4. Then I'm going to go sideways. I'm going to cut across with 3 thirds. And I'm going to double color with 2. 1, 2. So now my denominator, I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5, 6. And we can by what?
2.
So we can. I've heard 2. I've heard 3, and we really can do it by 6. So one strategy that I've done in the past when we're doing simplifying is take your 2 numbers and start a little list. What makes a 6? 1 times 6, 2 times 3. What makes 12? 1 times 12, 2 times 6, 3 times 4. And then what I'll do is I'll go across and I'll circle the numbers that match. 1, of course, even though, how would you do that? 2, 3, and then 6. And then to make it simpler, pick the biggest one so that you don't have to simplify more than once. So do the one that's bigger. So it's easier if you list it out. That way you don't have to try to remember it in your head. Write it down. There's nothing wrong with writing stuff down. So then also write it down. 2/3 times 3/4. 2 times 3, 6. 3 times 4, 12. And of course, as you know, it'll simplify. Easy. Easy?
Yeah.
Is what? Well, but can 12 go into 6?
No.
No. So the biggest number that can go into both would be 6.
Like
2 can go into...
volleyball.
No. But yeah. 2 can go into both. But then you have to simplify it again.
It's something like 12 divided by 6. Oh.
Alright. So, 3/4 of 4/5. So the first thing I'm going to do is show 4/5. So I'm going to separate it into 5 sections. And I'm going to shade in 4 of them. So there's 4/5. Now I got to do 3/4. So I'm going to go this way. And I'm going to do 3 of them. 1, 2, 3. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 20ths is what I've got double shaded. I know. I don't have any room over here to do it.
Okay.
3/4 times 4/5. 12 20ths. So if I think about my, what can make 12? 1 times 12. 2 times 6. 3 times 4. What can make a 20? 1 times 20. 2 times 10. 4 times 5. I've got 1, I've got 2, I've got 4. So I'm going to simplify by 4. And I've got 3 fifths.
That's all you can do.
Thank you.
I wrote it.
2/5 of 2/3. Separate this one into 3 parts. Shade in 2 of them. 1, 2, 2/5. I go this way, 5 parts. 1, 2, 3, 4. Shade in 2 of them. Oops. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 total pieces. 1, 2, 3, 4.
Why are we doing better? Like, are we doing 3?
Because that's a 3. And that's a 5.
Why did you separate it into 4 parts?
2, 3, 4, 5.
No, straight across. You put it into 4 parts.
1, 2, 3, 4, 5. I draw 4 lines, but it gives me 5 pieces.
I know, but it's only supposed to be 3.
1, 2, 3.
Oh.
1. Yeah. Two times 3 is the same as 3 times 2. Doesn't really matter. Okay, so if I do what makes a 4, you get 1 times 4 and 2 times 2. If you do 15, 1 times 15 and 3 times 5. They do not share a factor, so it does not simplify. 2/5 times 2/3. 2 times 2 is 4. 5 times 3 is 15. 4/5 of 2/3. 1, 2, 3. 2/3, shading in 2. 4/5. 1, 2, 3, 4. Just shade in 4 parts of them. 1, 2, 3, 4. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's harder for you guys because you're doing it in pencil, and I've got 2 different colors, and it's hard for you to see. But you're not going to have to do rectangular models all the time. Right now, you're just practicing how to model it. Pretty soon, you're going to be doing nothing but math.
Yeah.
If you continue to play with that book, the book's going on my table, and you're getting a U today. I'm looking at you. I'm talking to you. Or whatever it is you're messing with, your supply box. Well, that's even better. If you want to keep playing with that, it's going to go on my table too. Look like a book from where I was sitting. So, I'm doing math. I'm not doing anything that requires supplies other than a pencil that should already be on your desk. So 1, 2, 3, 4, 5, 6, 7, 8. So whatever makes an 8 will be 1 and 8. 2 times 4, 3 doesn't go. And then 15 is 1 and 15. 2 doesn't go. 3 and 5. 4 doesn't go. And then there's 5. So nothing shares, so it doesn't simplify. 4/5 times 2/3. 4 times 2 is 8. 5 times 3 is 15. And there that is. 2/3. So I'm going to separate this into thirds. 1, 2, and then 3/4. 1 part, 2 parts, 3 parts, 4 parts. Color in 3 of them. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6 are colored in. What makes a 6? 1 and 6, 2 and 3. 1 and 12, 2 and 6, 3 and 4. So I've got 2, 3, and a 6. The biggest thing is a 6.
I see.
And that makes simplifying easier?
Oh, yes, it really
You
does.
see your problem? Okay. So is it easier to fix it now? Easier to solve? Okay. So 3/4 times 2/3. 3 times 2 is 6. 4 times 3 is 12. And we already know that it can be simplified by a 6. Why not? Okay. Now, down on the bottom, this is something that we have done before, and I've probably got about enough time to do the example right here. You've done this before, and you see nowhere on here does it say do a rectangular model, but it just says if it helps you. So you don't have to do it. So the rectangular model was just like a how the math works kind of thing. So we're going to get into where you don't have to do it. So, and I know a lot of you don't like it. It just really messes you up. So, but you do have to know how to multiply. So with this one, I'm going to do the example and go through it, and then we'll step out for lunch. So 6/7 times 5/8. What they're doing is they're taking these two and they're doing what I call smooshing them together. Little smoosh math. So 6 times 5, they're smooshing the numerator together, Parker. And then 7 times 8, they smoosh those together. And so they're doing a little simplifying before we get the answer. Now, you don't have to do this. If it messes you up, don't do it. But at some point, you are going to have to do simplifying. So all they're asking you to do is if you see in the problem where something in the numerator, Parker, something in the numerator and denominator, Jacob, where they share a factor. Kind of like up here where 6 and 12, they can both be simplified by 6. Do you see something in the numerator and the denominator that can both be made smaller or simplified by the same number? What you do to the bottom, you have to do to the top. Do you see where they can be affected by the same number? You see where they can be simplified within the problem. Jeremy is saying 2. Now, 6 and 8, they can both be made smaller by 2. If I had a fraction and I ended up with 6/8, Wouldn't I say that can be simplified?
Yes.
So I can simplify this right here. I can say that the 6 and the 8 can both be, go ahead and divide those by 2. So the 6 divided by 2 would be 3. The 8 divided by 2 would be 4. Now, do the 5 and the 7 share anything?
No.
No, they're both prime numbers. 5 can't go into 7. 7 can't go into 5. They don't share anything but a 1.
Oh, that makes it easy.
So now 3 times 5 is 15. 7 times 4 is 28. And if what I did, you went, what on earth did you just do? You can still do 6 times 5 is 30. 7 times 8 is 56. But when you look at that, you're going to go, that's a huge fraction. And you're not going to want to do anything to it. You might not know, Parker, that that can't be, you may not know that that can be simplified. You may not know that 3 or 2, 3 can't go in that 2 can go in there. So it's easier sometimes to simplify when it's up here and not wait until it's so big that you don't know that something can go in there. See what I'm saying? So it's easier when you look up here and go, can I mess with these numbers up here and make them smaller so that you're not stuck with a big ugly fraction? Because if it's even, that's even. 30 divided by 2 is 15, 56. And so you would actually have to sit over here and do this. And then if you're not good at dividing, I mean really, that's too much. So isn't it easier just to do this? So we're going to practice that with these when we get back. So let me clear this off. All right, so with the 3/4 times the 5/6, then I'm going to do the smoosh math. So I'm going to smoosh these top two together. 3 times 5 over 5 times, 4 times 6. Whoops. Okay, so I can just go ahead and multiply it if I want to. I can, where I would end up with 15 over 24, and then I'm stuck having to simplify. But I can, where are your papers? I can go ahead and look at the problem before I've done any of that multiplying, and I can look and see, is there anything in the top that is shared in the bottom?
Yes, they have 3 and 6.
So the 3 and the 6 have something in common. So what do the 3 and the 6 have in common?
It's 3.
A 3. So the 3 and the 6 share a 3. So 3 can go into 3 one time. 3 can go into 6 2 times. What about 4 and 5? Do they share anything?
No, ma'am.
No, nothing. So 1 times 5 is 5. 4 times 2 is 8.
5/8.
So your answer is 5/8.
That's like you simplify in the very beginning.
I'm simplifying in the very beginning so that I don't have to simplify in the end. So 15/24 is ugly, but it's not wrong. I'm just stuck having to simplify here, where I would have to simplify by 3 here. And 15 divided by 3 would be 5. 24 divided by 3 would be 8. So I mean, I would have to simplify there, but since it's so big, I might not notice that it can be simplified by 3. So it's just easier when your numbers are smaller.
That way give me, for me, give me more mistakes.
This one? so then don't do it. This is not mandatory. You don't have to do this. This is just another strategy. Because if you leave me with 15/24ths, it's not wrong, it's just not finished. Because you're not going, and I can't think of how many times I said this in second quarter. I know I said it more than once. You're not going to find 15/24ths on your answer on a test that is multiple choice. If you start it, you finish it. This is incomplete. 5/8 is what you would find on a test that is multiple choice.
Anything that can be simplified in more areas.
Yes. So if you can simplify it, you need to simplify it. It has to be simplified. And so this just makes it to where it's easier to deal with. Because after a while, your numbers are going to get fairly large. And you may not notice because your fractions are going to be ugly. If that makes any sense. And you may not notice that they can be simplified. So with 15/24, if you're here and you don't know if they can be simplified, just do the thing that I taught you. 15. What makes 15? Well, 1 and 15, 3 and 5. What can make 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. And if you're looking and you're looking at your shared numbers, the only thing that they share is 3. So then simplify by 3. Start making your lists. It makes simplifying a lot easier. Yes, Jeremy?
I can see that the way but the diagram
What we were doing up here? Yeah.
you missed one. If you go wrong, start over. Like this, your numbers are right there.
Right. Well, again, a lot of times with the diagrams, all they're doing is just showing you the backstory for why the math works. The rectangular model is not something that you have to do. It's just showing you why the math works. How another way to get the answer. This is just another way to get the answer. You do. I'm going to wait on you guys to quit throwing all this paper away. All you need is this, the problem set. Get it wherever it is. Get it out. Quit worrying about other things. Yes, Jamarco? Absolutely. Go ahead and try these. So, we could do 4 times 5 over 5 times 8. Now you could do just multiply straight across. And you would end up with 20 40ths. That's one way to do it. Especially if you don't feel like. So, is this the final answer? Absolutely not. So, you could simplify by what?
10.
You could simplify by 10.
20.
I was thinking about
5.
20.
Well, I really only need just one answer here. So then this would be 2, this would be 4, you end up with 2 fourths.
But you can simplify that.
So then you can simplify by 2, and you end up with 1/2. So that's one way to do it. So there's more than one way to solve this. So that's one thing. So 4 times 5 over 5 times 8. Another way that you could do this is to see that 5 and 5 are shared. They're the same number. 5 and 5 both have 5 in common. So you could cross those out and make them a 1. And that's okay. If you didn't see it, now you know when you've got the same number top and bottom, turn them into a 1. Okay? So, because 5 divided by 5 is 1, 5 divided by 5 is 1. They're simplified by itself. Okay? I can also do 4 and 8. 4 and 8 have 4 in common. 4 simplified by 4 is 1. 8 simplified by 4 is 2. 1 times 1 is 1. 1 times 2 is 2. And I just saved myself all this work. Fine. Do all that work then. But if you're going to do all this work, you need to make sure that all this work is correct and all this work is finished. That's the thing. The work has to be finished. And that I know that it's an actual fraction. So this makes it a million times easier, but if you want to make it harder, here. I'm a work smarter, not harder kind of gal, but if you want to work harder, fine, just be accurate. Make sure I can read it, make sure it's there, make sure I can find your answer. Make sure it's there, as long as I can find your answer. Make sure I can find your answer. Because 9 times out of 10, y'all write a whole bunch of mess and think you're going to impress me, and then I can't find your answer. And it ends up being incorrect. Now, if you really are determined to draw a rectangular model, it needs to look like 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 5 of those. 4/5, so it's going to go 2, 3, 1, 2, 3, 4, 5 of those. And then you got to color in 4. Four rows of those suckers. Then you're studying 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then you got to count all of these. So then this ends up being more work when this is the easiest route. So I don't know if this is just a I want to waste time when this is the easiest route. I don't know. Because this, if you're going to do a rectangular model to give me an answer, in order to get credit, it has to be exactly right. It can't just be some kind of looking like that, and then you write some wackadoo answer, and you give me this, you give me that, and you got some mess that looks like that, and then you think I'm going to go, okay, that's a rectangular model, that looks good, and you think I'm going to be okay with this. When I say show work, your rectangular model has to look precise for me to give you credit for showing your work. So if you're determined to show a rectangular model instead of showing your work, it better be precise. So I recommend just don't do the rectangular model anymore as a means of showing work. Show work. Multiplication. You know how to do that. This was just starting it off. Don't. Just quit being hard-headed, people. Okay. Do C and D.
I want to do the.
So 2 times 6 over 3 times 7. Do we see anything that has anything in common?
6 and 3.
So 3 and 6 have something in common. So 3 and 6, they have something in common. 3 can go into 6. So 3 divided by 3 is 1. 6 divided by 3 is 2. Do 2 and 7 have anything in common? No. 2 times 2 is 4. 1 times 7, 7. Now I don't have to simplify. Now you can just multiply it, but you'd be left with 12 over 21. And you would have to simplify that. And that is an ugly fraction. And you'd be stuck having to simplify it by 3, but you might go, well, that's so ugly. That nothing can go into 12 and 21. And you might leave it alone, not realizing that 3 can go in there. So you might not mess with it. So 4 times 3 over 9 times 10. And if you just multiplied that, you'd have 12 over 90. And if you want to do that again, fine. But you know that you're going to be stuck having to simplify. So, it's just this, but why make it harder on yourself? So, I know that 3 can go into 9. So 3 divided by 3 is 1. 9 divided by 3 is 3. 4 and 10 have a common factor. 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Two 15s. Now, if you didn't do the 4 and the 10, then you would have had 4 over 30, and then you would have had to simplify it by 2. So, I mean, that's fine. You may not have noticed the 4 and the 10, and that's okay. Okay. So, with number 3, please pay attention. With number 3, Philip's family traveled. They traveled. Let me get to this page. Here we are. Philip's family traveled 3/10 of the distance to his grandmother's house on Saturday. They traveled 4/7 of the remaining distance on Sunday. What fraction of the total distance to his grandmother's house was traveled on Sunday? Now, is this a problem where I can go number, multiply?
No.
No. Now, one of the things I want you to see is we have that remaining distance thing on there. No, it's not that there's a remainder. It's not. I'm not dividing anything. I need to do what? Draw a tape diagram. So I need to draw a tape diagram. So right here, I need to know we're finding the total distance. Well, we're not really finding the total distance because it's not asking. What fraction of the total distance to his grandmother's house was traveled on Sunday? Now, So, how many parts do we need to put? How many sections do we need to place in our tape diagram? How many pieces do we need to put in it? So if they traveled 3/10 of the distance on Saturday, and they traveled 4/7 of the remaining distance on Sunday, how can you figure out how many pieces we need to put in the entire? Emma and Lexi, can you please close the books? Thank you. We're kind of doing math right now. Melena.
You need to put the diagram in 10.
Yes! Yes! Yay! Hug! Hug! Yay! So now you gotta say, Grandma, Mama, listen, I got hugs on the video. 10, because we've got tenths. Yay, Melena! So 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop it. So we know that there are 3/10 on Saturday. So we can go ahead and label this Saturday. Now I was kind of going over this while you were reading a book. Okay, so we have 3/10 on Saturday, and then they traveled 4/7 of the remaining distance on Sunday. So what am I going to do with that information, DeMarco?
Like you did the Saturday, you do the same as before Saturday.
So why do you think it's 4/7? Okay, so why am I only going to do 4?
Because 4 over 10, and when you did 3/10, you did 3 and 3 was on the top.
Okay. You're kind of dancing around it. I think you know it, but you just don't know how to say it.
There's 7 squares left, and it says 4/7 of the remaining
Because
squares.
when we took out the 3, how many are left?
7.
Because there are only 7 of the remaining. And right, there's only 7 left, and so 4/7 of the remaining. I know you're like, oh. So this was Sunday, 4/7 of the remaining. So what fraction of the total distance to his grandmother's house was traveled on Sunday? What fraction? So what would we call this fraction of the travel for Sunday? What would we really call this travel done on Sunday?
4/10.
4/10. Give DeMarco a gold star. 4/10. High five to you.
And then you can.
And that's it.
What got
And you can. And so what would it be?
it'll be
How many minutes? Marco.
It would. Very good. Well done. The heavens opened and the angels wept. Yay! Santino bought a 3/4 pound, a 3/4 pound bag of chocolate chips. I'm not even done reading the question. He used 2/3 of the bag while baking. How many pounds of chocolate chips did he use while baking? Is this one a number multiply to solve?
No. Oh, yes, yes.
Yes or no? I'm hearing no, yes, no, yes.
Yes.
He bought a 3/4 pound bag of chocolate chips. He used 2/3 of the bag.
Yes.
Yes. The bag weighed 3/4 of a pound. He used 2/3 of the bag.
That's it. This is a subtraction.
No, it is not. The bag, no. No. This is what the bag weighed. Was it a full pound?
No.
No.
It was a half.
So the bag weighed this much. He used this much.
Oh.
2/3 of it.
You can do like we did at the top.
Uh-huh.
Number pick out. It's 2 times 3 and it's 3.
How many pounds of chocolate chips did he use while baking?
Wow.
Oops. Don't sit on the mouse,
If you
Mr.
simplify
Klein.
it by 6. Yeah, you can't do that.
I mean, no, by 6. You have to simplify it by 6. I'm so dumb. You know what's difficult?
It's simply
Hmm.
You have to simplify by 6.
I bet I can make it even smaller than that. 3 and 3 become 1.
And 2 becomes 1.
2 becomes a 1, and the 4 becomes a 2, and the Diamond's got that down pat, don't you? You're like, let me find an easy way to do this stuff, right? 1/2 of a pound.
That's what I say. You said
Are you writing stuff down, or are you guys just sitting there carrying on a conversation? So I'm about to clear this off so I can move it. Because I heard y'all talk a whole lot, but I didn't see a whole lot of pencil moving there, Mila.
Oh, now I'm doing this stuff. What is this now?
Because sometimes you can pull number multiply. Sometimes you have to do a tape diagram. You have to pay attention to what the problem is actually saying. Go on. Quit playing with your string. Quit playing with your string. Take it off the pencil. Thank you. Farmer Dave harvested his corn. He stored 5/9 of his corn in one large silo and 3/4 of the remaining corn in a small silo. The rest, the silo are like those metal tube looking things that you see on the farm that have the dome top. That's a silo. The rest was taken to market to be sold. What fraction of the corn was sold in the small silo? Is this solved like number 4?
No.
No. Is this solved like number 3?
Yes.
Yes. So see if you can solve it. Use it. See if you can solve it. Do it. See if you can do it.
Okay.
No.
3/9.
Alright. So we have 1, 2, 3, 4, 5, 6, 7, 8, oops, 9.
Yes.
1, 2, 3, 4, 5.
Okay.
Large silo. 3/4 of the remaining corn. There were 1, 2, 3, 4 left. So 3/4 in a small silo. And the rest was taken to the market. So this right here was the market right there. What fraction of the corn was stored in the small silo? 1, 2, 3. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, which equals 1/3. 1/3.
Yay! And he took one mic to the mouth.
And he did. If he harvested 18 tons of corn, how many tons did he take to the market? How would you solve that?
You do 18. No, you do 1. You do 1 minus
18 1.
1 ninth of
18.
18.
And put a 1 under it.
But I can't. Oh. Simplify that would be 2.
It would be 2.
2 what?
2 tons. I said it before you, jerk. Doesn't matter. I made up the time. I made up the problem.
No, you didn't.
What?
Milano.
What?
I know, bro.
2 tons.
We're done.
And we're done.
We got homework. We can do this one.